Okay, we're going to start. Now I'm going to show you how to solve the seaboard trucking problem in Excel. And I know neither the formula bar nor the window, the solver window is going to come up, but I'm going to leave that to you. I think it'll be pretty self-explanatory as we go through this. But So let's dive in. These are the structure of these problems also makes it very easy to solve these in Excel, given the specific structure. All right, so let's look at first at our transportation problem. This is, as you remember, this is the data for the problem. These are the amounts of profit if you send a truck from Charlotte to St. Louis, and so forth. So what I'm going to do to structure this, I'm going to copy this. I'm hitting Control C, and then right below this, I'm going to go down a little bit. I'm going to go to here, Control V, and now what I'm going to do is I'm going to delete the information that's in here. And what this table becomes, this becomes your table of decision variables. That becomes your decision variables table. Okay, and it corresponds directly. So this cell is going to represent the cell CS, and we're going to leave this cell empty. But that cell, empty cell, represents the number of trucks that are sent from Charlotte to St. Louis and Charlotte to Atlanta and so forth. But these cells stay empty for our work. You'll also probably want to go back and reformat these and make these, instead of, because right now we copy down there, these would be dollars in those cells. You're going to want to make those just not currency, you're just going to make them a number, all right? And so now they're formatted as a number. Now somewhere on your spreadsheet, and I'm gonna put let's see, how can I do this? I want to put this right here. This is going to be our objective function. Type it in here. Oh, let's see if I can spell it correctly. Objective function. That's our, and I want to format that so it's aligned over to the left. And so in this cell is going to be, and I want to highlight that. That's going to be where our objective function is. And so our objective function, this is where it helps to use the sum product function, because we're going to end up using the sum product of these cells, the cost cells, with respect, and also along with respect to our decision variable cells. So we're going to type sum product of our respective profits, comma, then with our decision variables. And so then that becomes our objective function. And let's say, for example, if I send one truck from Memphis to Atlanta, then we make $700. And I want to format this as not a number, but I want this to be a dollar amount. Okay. And so then if I send a truck from Charlotte to St. Louis, it's $2,500 because it's 1,800 plus 7. And if I send 2 trucks, then that's going to be $3,600. So and so forth. So now we know that this works. And then the next thing that we want to construct is our, I want to reduce this just a little bit, get a little more room. Next thing that we want to do is realize that this row represents, again, this represents the decision variable CS, CA, CN. That's what they represent. And if you'll notice, if we take the sum of those three rows, CS plus CA plus CN, that's going to represent the total number of trucks that leave the respective locations. So in this cell adjacent to it, I'm going to calculate the sum of the, oops, not those, but these three cells. And that is the number of trucks that leave Charlotte. And now if I take this indicator in the lower right corner of this cell, I can drag it down, and each one of these cells is going to have the sum. And so these are trucks out of those locations. And what I want you to see is that this column represents CS plus MS plus LS. These are the trucks in this cell, which is cell C13. If we put the sum of these cells, that's the total number of trucks that will be going into St. Louis. And now I can drag this across, and that calculates the number of trucks going into each one of these locations. So these are the trucks coming to St. Louis from Charlotte, from Memphis, and coming to St. Louis from Louisville. And so we know from our problem formulation, let me put, these are trucks in, trucks out, and trucks in, that we know that, I'm going to have to refer back to the problem. We know that the trucks out, that at most, there's 40 trucks out leaving. And let me reduce this again a little bit, run it. I'm trying to. The trucks, we have a limit of 40 trucks out of Charlotte. Whoops, not 4, but 40. We have a limit of 40 out of Memphis, 40 out of St. Louis, and we have a limit of what can be accepted into St. Louis. The limit that can go into St. Louis is, let me read the problem again. St. Louis can accommodate up to 40. Atlanta can accommodate up to 60. And New York can accommodate up to 50. So those are the limits. And I'm just formatting here, put them in the center of the cell. So those are the limits. And so now believe it or not, we're ready to formulate this, or to solve this problem in Excel. I think what I'll do when I get through with this, I will include what I will do is I will include the solver window for this problem, the finished solver window, so you can see how it fits together. So anyway, now we're ready to solve. So I'm going to go to the Data tab. I'm going to click on the Data tab. We'll go all the way over to the right to the solver icon. The solver window comes up, and again, you're not going to see this, but I'll take a screenshot and put this up on the PowerPoint file. We select the objective function cell. It's a maximization problem. Select that radio button. Then we're going to highlight the three. You can see that I've highlighted there the objective function. You can't see, but I've selected the maximization radio button. I'm going to highlight now the changing variable cells, which are decision variable cells. Those are our decision variables. And then I'm going to add the constraints. And because the constraints are together and they're all of similar form, I'm going to add the set of constraints. These are our trucks leaving the respective location, those three, and they all have to be less than or equal to each one of these those values of 40. I'm going to add another set of constraints. The trucks in, which is cells C13 to E13, have to be less than or equal to cells C13 have to be less than or equal to these three cells. That's all the constraints. I'm going to make it unconstrained, name negative. I'm going to select simplex linear programming. I'm going to solve. And solver found a solution. Now this is interesting. You'll notice, I'm going to blow this back up a little bit. What's happened here? Why are these, did something wrong happen? And the answer is no, there's nothing wrong. It's just there's more digits displayed than there's room in that cell. So we're going to select that column and double click, and it'll expand and show that that's your solution. The profit is $212,000. You're going to send 40 trucks from Memphis to St. Louis, 40 from Charlotte to Atlanta, and 40 from Louisville to New York, and you're going to make $212,000. And that's the solution. So what I'm going to do is, again, I'm going to go back and put the screenshot of that solver window into the PowerPoint briefing so you can look at that. And then I'm going to leave this one here. This is the machine shop problem that we just formulated. And I'm going to leave that to you to solve, but I encourage you to go and try to solve that. It'll be very helpful for the quiz. Well, it'll be very helpful for you to get that experience, not for the quiz, but to try to do that on your own. And you should be able to do that fairly easily. And if you have questions, come to the session and ask, or email me and ask if you need help. Okay, that should do it. Thank you.